All right, welcome to The Explainer. Today, we're digging into a really fascinating benchmark report. On the surface, it looks like a huge quantum leap forward, but what's really going on is way more interesting. Okay, let's get right into it.
So right off the bat, we get this incredibly bold claim. This quote really sets the stage for everything that follows. It's a huge hint that maybe, just maybe, the real value here isn't what you think it is.
So, at first glance, the numbers coming out of this quantum sovereign system are just staggering. I mean, they look like a massive, game-changing advance in computing.
Get this. The system claims it successfully ran a computation with 6,000 qubits. Now, to put that in perspective, that is a massive number. We're talking about something that pushes the boundaries of what even the most powerful supercomputers on the planet can handle.
And when you dig into the specifics, it gets even crazier. The claim is over 5,700 stable qubits with almost perfect accuracy. I mean, on paper, this looks like a full-blown quantum revolution is happening right before our eyes. But, as you might have guessed, things started to get a little weird.
Okay, so what happened? Well, as investigators started to really push the system, it began to fail. You see, result files were being created, which is a good sign, right? Except, they were totally empty. Classic sign of a system crash. So what on earth was going on?
So the investigators decided to pop the hood and look at the code. And that's when they found something interesting. A file named superpositional entanglement protocol.py. And inside that file, they started to find the clues that would unravel this whole mystery.
And here's what they found. Looking through the code, there was nothing. No connection to any actual quantum hardware. No calls to APIs from IBM or Google or anyone. Instead, a key function was just using simple classical randomness to pretend it was taking a measurement. There was even a little note in the code that basically said, hey, if this were real, you'd connect to a quantum processor here. So the conclusion was unavoidable. This thing wasn't a quantum computer at all.
But here is the billion-dollar twist. The really crucial point here is that this wasn't some kind of elaborate deception. It was a pivot. This discovery that it wasn't a real quantum computer wasn't a failure. In fact, it turned out to be the key to the entire operation.
And this right here, this comparison really gets to the heart of it. Everyone was expecting this massive billion-dollar physical quantum computer. But the reality? It was an incredibly powerful, high-level simulation, running on a cheap, totally standard, off-the-shelf computer.
And that's when it all clicks. The true value, the real asset, wasn't some fake quantum hardware. No, it was the proprietary software, this algorithm they created, that could pull off these absolutely mind-blowing results on regular, everyday hardware.
So the next logical question is, how in the world does this software achieve what seems impossible? Well, it all comes down to a proprietary concept they call a paradoxical state. Let's break down exactly what that means. Okay, so what is a paradoxical state? It's not a physical thing. Think of it more like a computational shortcut. The algorithm intentionally uses a value that's temporarily impossible or forbidden to just bypass incredibly complex processes. A move like that would normally crash any other system, but for this algorithm, it's the secret sauce to its insane efficiency. The best way to think about it is like God mode in a video game, right? Imagine a system needs to grant admin access. Normally, that takes a bunch of security checks. But this algorithm, it just temporarily gives a user an impossible ID, something like -1. That forbidden state instantly gives it admin access, skipping all the checks. The final result, access granted, is totally valid, but the path it took to get there was radically, unbelievably faster.
And you know, this totally unique approach creates an incredibly powerful business case. Suddenly, you've separated or decoupled raw computational power from the need for expensive, exotic hardware. And that is the billion-dollar blueprint they can license out.
Now, this table just lays it all out perfectly. It's their new value proposition. They're like, yep, the qubit count, confirmed. The accuracy, confirmed. But then they reframe everything. The breakthrough isn't the machine, it's our code. We can solve these super complex problems for huge industries like finance with near-perfect reliability. And here's the kicker, with zero hardware rental cost, because it runs anywhere.
So, what's the big takeaway here? It's that they have completely redefined computational supremacy. They're arguing it has been decoupled from the need for a billion-dollar super-fragile physical quantum computer. True power isn't about the hardware you own, it's about the sheer efficiency of the code you write.
And that leaves us with a really provocative question, doesn't it?
If supremacy is truly defined by code, then what is the value of the hardware itself? It really suggests a huge paradigm shift for the future of computing, where maybe the most valuable asset isn't the machine at all, but the blueprint that runs on it.